Two complex numbers are u, which equals 3 plus 2i, and v, which equals minus 1 plus I, where I squared equals minus 1. Part A. Given that w equals u minus v minus 2, evaluate w. So what we're going to do is substitute. We're going to swap the letters for brackets and put the numbers into the brackets. In this case, the complex numbers. So we have u minus v minus 2. So we're going to swap u for 3 plus 2i with brackets around it. Bring down the minus. Swap the v for minus 1 plus I with brackets around it. And bring down the minus 2. The 3 plus 2i has nothing in front of the brackets. We can just write that down as it is. 3 plus 2i. Minus 1 is plus 1, because a minus multiplied by minus is a plus. And minus plus I is going to be minus I. A minus by plus is a minus. So minus plus I is minus I, and then we bring down the minus 2. Now we need to group the real and imaginary parts together. So 3 plus 1 is 4, and 4 minus 2 is 2. So the real part always comes first. So we have 2 for a real part. And then 2i minus I is the same thing as 2i minus 1i. And 2 minus 1 is 1. And 1i is just I. So 2i minus I leaves us with plus I. So we get 2 plus I for w. Part B. Plot u, v and w on the Argand diagram below. So this is our real axis, and this is our imaginary axis. So u is equal to 3 plus 2i. So we go across to 3 on the real axis, and up to 2 on the imaginary axis, and we end up getting the point u. So across to 3 on the real axis, and up to 2 on the imaginary axis, and we get the point u. Then v is minus 1 plus I, which is the same thing as minus 1 plus 1i. So we go to minus 1 on the real axis and plus 1 on the imaginary axis, and we plot our point v. So minus 1 on the real axis and plus 1 on the imaginary axis, and we get the point v. And then w we worked out in the last question. We got to be 2 plus I, and 2 plus I is the same thing as 2 plus 1i. So we go to 2 on the real axis and 1 on the imaginary axis, and we plot our point w. So 2 on the real axis, 1 on the imaginary axis, and we plot our point w. Part C. Find 2u plus v divided by w, where u is equal to 3 plus 2i, v is equal to minus 1 plus I, and w is equal to 2 plus I. So we have a formula, and we're going to substitute into our formula, and we're going to swap the letters for brackets and put into the brackets whatever the letters are equal to. So we're going to bring down the 2 and then swap the u for a set of brackets and put 3 plus 2i into the brackets. We're going to bring down that plus and swap the v for brackets and put minus 1 plus I into those brackets. Bring down our divide sign and then swap the w for brackets and put 2 plus I into the brackets. Then we're going to multiply out whatever we can and simplify. So 2 multiplied by 3 is 6, and 2 multiplied by 2i is 4i. Plus minus 1 is just minus 1, a plus by minus is a minus, and plus I is plus I, a plus by plus is a plus. There's nothing in front of this set of brackets, so we just write down what's inside the brackets, 2 plus I. So we get 6 plus 4i minus 1 plus I, all over 2 plus I. We're going to put the real parts together, so 6 minus 1 is 5, and the imaginary parts together, 4i plus 1i is 5i. And that's still over 2 plus I. So now we have two complex numbers that we need to divide, and the rule for dividing complex numbers is we multiply the numerator and the denominator, so the top and the bottom of the fraction, by the conjugate of the denominator. So the denominator is 2 plus I, and to get the conjugate of a complex number, we just change the sign of the I. So 2 plus I, the conjugate of that will be 2 minus I. So we're going to multiply the top and the bottom by the denominator with the opposite sign. So we multiply 5 plus 5I by 2 minus I, and then 2 plus I by 2 minus I as well. So 2 minus I is the conjugate of 2 plus I. So to get the conjugate of a complex number, you just change the sign of the I. So plus becomes minus. If it was a minus to begin with, it will become a plus. So then I'm going to work out the numerator. 5 plus 5I times 2 minus I up here. So I'm going to break open this bracket, and I'm going to have 5 multiplied by 2 minus I, and plus 5I multiplied by 2 minus I. 5 by 2 is 10. 5 by minus I is minus 5I. 5I by 2 is plus 10I. 5I by minus I is minus 5I squared. Then we're going to group together our imaginary parts. So minus 5I plus 10I is plus 5I, bring down to 10. And then I squared changes to minus 1 with brackets around it. It must have brackets around it. So we get minus 5 multiplied by minus 1 is plus 5. Then we can group together the real parts. 10 plus 5 is 15, and bring down to 5I. So our numerator is now 15 plus 5I. So this multiplied out to become 15 plus 5I. Now we're going to multiply out the bottom part of the fraction, or a denominator. So 2 plus I multiplied by 2 minus I. So we're going to have 2 multiplied by 2 minus I, plus I multiplied by 2 minus I. So 2 multiplied by 2 is 4. 2 multiplied by minus I is minus 2I. I multiplied by 2 is plus 2I. I multiplied by minus I is minus I squared. Minus 2I and plus 2I will cancel each other out. So we have 4 minus I squared. We swap I squared for minus 1 with brackets around it. Very, very important, we have brackets around it. Minus by minus is a plus. So we get 4 plus 1. And 4 plus 1 is 5. So our denominator is now 5. So this multiplied out to give us 5. So then we put the numerator, which is 15 plus 5I, over the denominator, which is 5. Let's get 15 plus 5I over 5. We break up the real part from the imaginary part. So we have 15 over 5 for the real part, and 5I over 5 for the imaginary part. 15 divided by 5 is 3, and 5 divided by 5 is 1. So we get 1I, which is just I. So our final answer is 3 plus I.